Okay, related rates. The short way of explaining what related rates are is this is just implicit derivatives again. Except for it's not dy over dx anymore, it's d something over dt. And it's usually how one quantity changes with respect to time, or how the relationship between two quantities change with respect to time. So this is just going to be digging formulas out of your heads from previous years and asking you, first of all, what is the formula, and then what does its derivative look like? Okay. It's not that bad. The radius r and the area a of a circle are related to by the equation a equals pi r squared. Write an equation that relates the rate of change of area to the rate of change of its radius. So dA dt equals, write the pi down, cover it up with your thumb, and what is the derivative of r squared? 2r, and you need the chain rule here, kids. dr dt, the derivative of the inside. Side S and the area A of a square are related by the equation A equals S squared. Write an equation that relates the area, the rate of change of its area, to the rate of change of its side length. dA dt equals 2s ds dt. Don't not forget the implicit derivatives. It's not just 2s anymore. It's because the rate of change at which the side length is changing. It's changing with respect to time. Okay, it's not, we're so used to doing this, right? That's because x changes with respect to x. But now that's why it's not there. But because it actually is there, but dx over dx is 1. That's why we don't put it there. Okay? So the derivative of the volume, v equals 4/3 pi r cubed, dv dt equals 4/3 pi, covered up with your thumb, times 3r squared dr over dt. Yeah, but r prime, while r prime is correct, it doesn't give you enough information because r prime means r is changing, but with respect to what variable? Like what quantity? Yes, but you don't get to write r prime here. You have to use Leibniz's notation, which is what I'm doing. Okay? It's just, I think, yeah, I don't need to say anything about that. I think part of the problem is I really allowed a lot of r prime early, or y prime or x prime, and I didn't use dy by dx as much as I probably should have, and that's why people do it, write it like that. Okay, a balloon is filled with air. What is the relationship between the rate of change of its volume and the rate of change of its radius? So you have to visualize what shape are we talking about here when you blow air into a balloon. A sphere, so you just copy this formula and you're finished. Okay. Yeah, it's sphere-ish. That's about what we're going to do right now. So, what is the rate of increase of the volume of a balloon when its radius is 3 centimeters and the radius is increasing at a rate of 2 centimeters per second? So you grab the formula from the previous page, dv dt equals 4 pi r squared dr dt, and then all you do is drag and drop the numbers. 3 goes in for r, 2 goes in for dr dt, so 4 pi times 3 centimeters squared times 2 centimeters per second. Yeah, but the 3's cancel. We tend to leave pies in our answers. We don't work them out as decimals. So you go 4 times 3 is 12, times 3 is 36, times 2 is 72. 72 pi. Yeah, you just drop everything where it needs to go. Units are centimeters times centimeters times centimeters per second. Centimeters cubed per second. Yeah. Yeah, if you just think about what the question is about, yeah. Or the other way to do it is to use, in physics, you guys talk about unit analysis? Okay, forget it then. Well, all I did was go centimeters times centimeters times centimeters. Oh, it's centimeters cubed. That's called unit analysis. The radius of a circular disk at the rate of 3 centimeters per second. What rate is the area changing when the radius is 4? So the formula for the area of a circle is pi r squared. The derivative is which number goes where? Now you just got to put, where do the numbers go? dA over dt equals 2 pi times 4 times 3. Holy, that's brutal handwriting. Well, times 2 is 24, 24 pi centimeters squared per second. You get the idea? Do we want to do this one? Put in 9 for ds dt, put 3 in for s. 2 times 3 times 9. 6 times 9, 54 centimeters squared per second. Okay. Starting to become more interesting. Water is being poured into the container of the shape of a cylinder, 4 centimeters high and 2 centimeters in radius, at a rate of 6 cubic centimeters per second. Now, what rate does the surface of the water rise? So you draw a cylinder if you need to. I don't need to, but that's R, that's H. Formula for the volume of a cylinder is pi r squared H. Then you have a freak out. Mr. App, there's 2 variables here. I need to use the product rule. No, you don't. Why not? No, H changes. R doesn't. When you pour water into a container, does its radius change? No, unless you're using, and then the example this morning was one of those rubberized bladders that they use in the field when they're fighting forest fires. When they put water into the bladder, the radius does change. What? No. R doesn't change, H does. As you pour water into a container, its height goes up. No, but the water's height does. Right. I can make the container's height change too if you'd like to make it a piece of ceramic, soft ceramics, and you're spinning it on a wheel in the art room and while you're filling it up with water. Yeah, no. So dV dt equals pi r squared times dH dt. So you have to treat all of this as a constant. Okay? That's the trick for the question, is realizing that the radius doesn't actually change. So it says, at what rate does the surface of the water rise? So I want to know what dH dt is. Question mark. 6. Yeah. So 6 equals pi times 2 squared times dH dt. So you get 6 over 4 pi equals dH dt. 3 over 2 pi centimeters per second. Notice we didn't even need the height of the cylinder because it doesn't matter. The only thing that matters is the radius of the cylinder. Tricky? Maybe a little bit. Well, if you treat all of that as a constant, the derivative of pi r squared, like, what's the derivative of 8x? 8 times the derivative of x, right? Same thing. It's just the 8 is very complicated. It's pi r squared, but it's still 8. Still constants. Okay. Flipping page. Water is being poured into a container the shape of a rectangular box with a square base, 4 by 4 by 12, at a rate of 50 cubic centimeters per minute. At what rate does the surface of the water rise? Until the box fails and all sorts of cool things happen. Boss? Yeah. Okay. So x times h. V equals x squared h. Oh. dV dt equals yep. Now why didn't I do anything with this? Because it's a constant. So put 50 in for x, put in 50 in for x. Put 50 in for dV dt, put 4 in for x, and find dH dt. No. So 50 equals 4 squared times dH dt. (25 over 8 centimeters per minute). Three-ish. Going up at a rate about 3 centimeters per minute. So in about 4 minutes, if the tank is just about 4 minutes, the tank's going to be overflowing, right? Yeah. Okay. Yeah. Okay. So that's all in how you read the question. At what rate? So that's telling you what you want to solve for. The surface of the water rise. When you think about water rising, you're talking about height. Yeah, and that's volume. Yeah. Okay, so let's do that with this one. A conical reservoir, cone, is filled with water at a constant rate of 6 cubic meters per minute. What are we saying here? What is 6 cubic meters per minute? dV dt equals 6 meters cubed per minute. A reservoir is 3 meters deep and 8 meters diameter at the top. So I need to look at the AP exam a little bit closer, but my initial reaction is know them. You look it all up. I know. Hey, look. I don't make the rules. Yeah, I know. I'm trying to hint at something. So, because when you write the formula for the volume of a cone down, when you write the formula down for the volume of a cone, there are R's and H's in here, and they are both changing as you pour water into a cone. So, one would think that you would have to use the product rule here, but you don't. You have to read because there's a relationship between the black cone and the blue cone. They're the same. They're similar triangles, are they not? If I do this, the triangles are similar. So you can write a relationship about the sides of the triangles with respect to each other. There's about 8 million different formulas you could write here. You could write 4 is to AR as 3 is to H. You could write 4 is to 3 as R is to H. You could write R is to 4 as H is to 3. No. Keep going. I'm going to stop right about there. I tend to like my variables in the numerator, so I will write R over 4 is the same as H over 3. So you read the question. It says, find the rate at which the surface level of the water is rising. That is talking about H. I only want that volume formula to have H's in it. So I'm going to solve the formula that I just created in the bottom left corner of the screen and solve it for R. So R equals 4H over 3. You betcha. Clean it up. P equals 16 pi over 27 H cubed. Take the derivative. dV dt equals 16 pi over 27 times 3h squared dh dt. Yeah. So now you know everything. What goes in for dV dt? 6. What goes in for h? 2. So 6 equals 16 pi over 27 times 3 times 2 squared times dh dt. Then it's just clean it up. I don't know, 6 times 27 divided by 16 times pi times 3 times 4. Whatever that is. Is it? Well, 6 cancels with the 3 here and the 2 there, and then the what? Quit picking on me. What? 1 over 2. Well, there's lots of ways of doing it. Yeah, it's 27 over 32 pi, is it not? I got that. Centimeters per second. Okay. Are we good? That's it. That's all for today. You have an hour? Good. Good. So you have, what do you have to work on? You have any chapter 4 homework, the 4.1 to 4.3 assignment, and then the 4.4 to 4.6 assignment. You just got that one right now. The only question you don't know how to do on that one is number 6. You can do all the other ones. Okay.